Good evening. Welcome to ACE Preparation League. I am Professor C.H. Ganapathi Reddy. Today's class is Network Theory. So keeping some important topics in mind, I am going to solve one or two problems in each topic. The problems which I selected is keeping previous gate questions in mind. So with the help of these problems, I am going to cover important concept, what is that you should know to solve the problem. So let us start with this problem. So it is based on RAB or equivalent resistance. This equivalent resistance is very important in theorems, especially Thevenin's and Norton's theorem. Second, also useful in all single source problems. It can be voltage division, current division, etc. Definitely we solve with the help of R equivalent or L equivalent or C equivalent. Then this concept is also useful in transient analysis, especially in first order circuit when we are finding tau of RL circuit or RC circuit. There also we apply R equivalent. So series parallel concept is important, compulsorily should know. There are n number of problems to understand this. I am solving one or two problems. So what is the definition of series parallel? It is based on connection among the elements looking from the source. So here when we are answering RAB, looking from the source means imagine there is a source connected here. So we are finding RAB from here. Now if we observe this problem for 10 minutes also, difficult to decide how they are connected because of complexity of the connection. These two nodes are connected, these two are connected, then difficult to decide how they are connected. So brain cannot imagine to decide which are series, which are parallel. So there is a small technique I will tell you. So because this is shorted, I am assuming one node X. If this is X, obviously this is also X. If this is Y, this is also Y. Now with the help of X and Y, and redraw the circuit. So when we are redrawing, this is R1, A, this node is X. So this R1 is drawn. Next R2 is connected between X and Y. X and Y, so here also Y is there. Let me take B here and another node Y. So R2 is across X and Y is R2. Then R3 also between this node is X and Y. R3. Next R4 is also between X and Y. Then lastly R5 between B and Y. So this is B, Y, this is R5. Easily we can decide what is RAB now. Looking at circuit, what is RAB? R1 plus, these three are parallel. 2 parallel with R3 parallel with R4, that is series with R5. If numericals are given, we can find out the answer. So specialty of this problem is, if there is any confusion, by introducing variables like this and by redrawing, easily you can simplify RAB. Now let us see second problem. This is another problem based on R equivalent. So it's a lattice network. So many networks are there: T network, pi network, bridge T, lattice, ladder, etc. This is another complicated model, lattice, cross connected. Now we want to answer RAB, CD, etc. So to find RAB, looking from AB, and of course CD is open. CD is open. So how to find RAB? So general rule is, imagine you are entering from A, now you should come back to B. Or imagine you are sending some current from A, same current should come back. But how this current will divide? So there is a division here, some current will go here, some current flow like this. But this current cannot go here because it is open. Same current will come here. And this current will come here, it cannot go this side. So it has to come here. This current is same, this current is same, and these two currents added up again coming back to B. Now observe the properties. Current same means series. Here also current same means series. And that and this parallel because here current divided current again combined here. So between these two nodes, definitely they must be parallel. So what is RAB answer now? R1 plus R3 plus R3 series parallel with 4 plus R2. 4 plus R2. This is RAB. Like that we have to answer remaining. Next RCD. When RCD we are looking from CD, then this is open. Looking from CD, AB is open. So this is similar to previous almost. Now we are sending current from C, again dividing, this current coming here up to here. This current is flowing like this. So here dividing, combining here. So R1, R4 series. R1 plus R4, which are parallel with 3 plus R2. So like this we can answer R3 plus R2. This is RCD. So these two done. Next RAD. RAD. How to answer this? AD. Our focus is, imagine you are entering from A, then go to D. To D, how many ways we can go? So this is one path through R4. Second path is R1, R3, again R2. We have to reach to this destination D. So this current dividing here and here. So this current is R4 here, and here this current is same, here it is same, here also same. So here current same means these three are connected in series. So R1 plus R3 plus R2, these three are in series parallel with R4. So this is the answer. Same way, how to find RAC? If it is RAC, A to C, this is one path. This is one path, that is R1. A to C, this is straightforward, and we go like this. This is another way. So R4, R2, R3. 4 plus R2 plus R3. Like that we can find the RAC. Then RBD. RBD. R2 is parallel with C to D is this one path. Second path is this. So R3, R1, R4. C plus R1 plus R4. So like this you can find RBD, RBC also you can try. So this is one basic problem. How many ways we can find? So total 6 combinations we can work out. And what is the importance of this problem? You can connect voltage source, find currents everywhere. It can be current, it can be voltage, it can be power, it can be energy. If time is given, you can also find energy. And the source can be connected here, source can be connected here, or across AC, or across BD, or across BC. It can be voltage source, it can be current source. With current source, they may ask to find voltage, or with voltage source, they can ask you to find current, and so on. So we can create so many problems in this, but based on series parallel. If series parallel is wrong, then you apply wrongly current division and voltage division, end up with the wrong answer. So series parallel will play important role. Let's see another problem. Nodal and mesh analysis. Nodal and mesh analysis. Based on nodal and mesh. Nodal and mesh is a very powerful tool. It is like AK-47. Using AK-47 you can kill any animal. You can solve any problem in the world using nodal and mesh. What is the drawback of single source problem? If it is a single source, all single source problems using voltage division, current division, easily we can solve. More than one source, don't apply series, don't apply parallel. This is very, very important concept you should remember. More than one source, never think of series or parallel. Never apply voltage division, current division, flux division, charge division, and so on. If it is more than source, you should use only either nodal or mesh analysis. So this is one problem I am taking. It contains independent voltage sources, one independent current source, and this is current dependent voltage source. Current dependent voltage source. This is voltage dependent voltage source. So V3. Voltage dependent voltage source. IX, current dependent again voltage source. Independent current source. Independent voltage sources. So many different sources are there. Another 2 combination of dependent sources not taken. So in this problem, find IX. So I will solve IX using nodal and mesh analysis. In the GATE exam, they never mention the technique. Use nodal or mesh, they never mention. They will ask you to find IX, or they ask you to find VX, or find so and so. What is the method you have to apply? Based on your experience, you have to decide. So that is important. So let me use nodal. Is a nodal. What is the voltage here? Obviously 0, because it is connected to ground. What is the voltage here? Whether we know it or not, we don't know. This voltage we don't know. This voltage we don't know. This voltage, if you know this, using this you can find here. So I am assuming some voltage here, maybe some Vx. So this is unknown, I am introducing Vx. If this is Vx, what is the voltage here? This is known, this is also known. What is the experience is important here is optimize the number of unknowns. If you introduce, keep on more number of unknowns, then more equations, more time, more mistakes, end up with the wrong answer. So optimizing the number of unknowns are very, very important. So this is unavoidable Vx. Then what is the voltage here? Don't take Vy, another unknown. This is known, these two are known. So compulsory it is minus V3, start here, go to ground, following KVL sign convention. Minus V3, then minus Ix R3. Minus V3, it is opposite direction, minus Ix R3. So I have not introduced any extra unknown. In terms of this only I have written here. Then what is the voltage here? Again, don't introduce extra unknown. This is known, this is known. So this is also known. Don't take here Vy, here Vz, not necessary. So what is the rule? Start here, go to ground. Start here, go to ground, following KVL sign convention. So using that convention, what is the voltage here? V2 minus V3 minus Ix R3. So this and this algebraic sum of this and this will be this. So this only I introduced, this is known, and in the problem itself Ix is another unknown. So that is already there. So finally how many unknowns are there? Number of unknowns. Only two. Only two. Problem looks bigger, but number of unknowns are only two. But unexperienced student, how they do it? They introduce Vx, Vy, Vz, three unknowns. Already Ix is there. It will become four unknowns problem. So four unknowns problem means four equations. Obviously it takes more time. But if you use logic, it is coming only two unknowns. So that is very, very important. Because of two unknowns, only two equations. Then where you can write, how you can write. One equation is here. One equation is here. And we can't write the equation here because of only voltage source. If there is only voltage source between two principal nodes, compulsorily we should go for a super node. So this will form one super node. This will form one super node. This is called as super node. When there is only voltage source between two principal nodes, compulsorily we should go for a super node. And two nodes, two equations. Now you can assume all currents are leaving. You can assume all currents are leaving. This is our choice. You can assume all are leaving, all are entering, some are leaving. It is totally our choice. So I am assuming this is entering. This is leaving, this is leaving. So this current will come up to here. So entering. Then here already entering. Here Ix is entering. Here I can assume leaving. Then we can write the equations. So here this is entering, this is leaving, this is leaving. Sum of the currents entering equal to sum of the currents leaving. So what is the current entering here? So this is important. How to write nodal equation is important. I am just applying Ohm's law. What is the voltage here? Voltage here is 4Ix. What is the voltage here? Vx. Which direction we want to find current? This side. So 4Ix minus Vx by R4. So equation 4Ix minus x by R4 is the current entering, is equal to current leaving, I is leaving, plus this current is leaving. So what is this current? How to write this? Keep your attention on R2. Find voltage here, find voltage here. So what is the voltage here? Start here, go to ground. This is nothing but 2V3 plus Vx. Plus Vx. That is the voltage here. Then what is the voltage here? Already there. This minus this by R2. So 2V3 minus of 2 minus V3 minus Ix 3 by R2. So this is one equation. Simple, this voltage minus this voltage by R2. So this is entering, these two are leaving. So that is over. Next, this current entering, this current entering, this is entering, this is leaving. So what is the current here? Here Ix is entering already. Ix is entering. Here I is entering. Entering is this term. Same. V3 plus Vx minus V2 minus V3 minus Ix minus V2 minus V3 by R2. These are the three currents entering, is equal to leaving this current. So this current is nothing but this voltage minus V1 by R1. So what is the voltage there? 2 minus V3 minus Ix R3 by R minus 1 V1 by R1. This is second equation. This is first equation. So solve these two equations. Find out what? Question is find Ix. So numerical values not given. If it is given, the simplification will be easy. You can solve. So how many concepts I am telling? Supernode concept, how to optimize the number of unknowns, then how to write nodal equation at normal node, how to write at supernode, etc. So this is one important model of nodal analysis. Now let us see how to solve same problem using mesh analysis. So I am erasing. So let me use now using mesh analysis. Mesh analysis, the powerful technique is current distribution method. Current distribution is best method. Any problem easily we can solve. So that method is very simple. This is the unknown already there. So what is the current here? Ix. So this Ix is already known. Is already there Ix. And this current I already there. This is also known. So obviously what is this current? X plus I. X plus I. This current will divide. Some current will flow here, some current will flow here. So what is this? We don't know. What is this? We don't know. Introduce one more unknown. So that unknown, if I take some I1, some I1, if this is I1, what is this current? Ix plus I is entering, I1 is leaving. So minus. So this is known, then what is this current? This I1 is entering, Ix is leaving. So I1 minus Ix. Every branch, what is the current is known. Just observe carefully. Here I1 is known, Ix, I1 minus Ix. Here we know, here everywhere known. Now check how many unknowns are there. An entire problem in this current distribution method, how many unknowns we are coming across. One is Ix already there in the problem. We introduced only one unknown, I1. So again two unknowns problem and we need two equations and solve. What are those two equations? One mesh equation we can write here. Remember, when we are writing mesh equation, see that no current source in the loop. Whenever we are writing mesh equation, see that no current source. That is only the important rule. Here you can't write mesh equation. Why? There is a current source. Here you can't write mesh equation. Why? There is a current source. But two unknowns are there, two equations we have to write. One possible equation is this allowed. But what is the second? This second not allowed, this second not allowed. But how would you take this other one? It is Ix. This current is I. This is I plus Ix. Current further, some current will flow here, some current will flow here. I am introducing one unknown, I1. And this is I. Total number of unknowns are Ix and I. Because of two unknowns, two equations. One mesh equation we can consider in this loop. This is accepted. And this mesh equation not accepted. The reason is there is a current source. So only one important thumb rule in mesh analysis is, and don't form a mesh equation when there is a current source anywhere. So this is not allowed. This is also not allowed. This is not allowed. So what is the other way you can write? We can take outside, outer loop. Outer loop, no current source. Here, no current source. So these two are valid. If I consider this one, if I started here, minus V1 and opposite direction, minus R1 I1 plus V2 minus V3 equal to 0. So what is the sign convention? Going from negative to positive is minus, positive to negative is plus. In the resistor, our direction, current direction opposite is minus, same direction is plus. So this is the convention. I take outer loop, if I start here, R2 into I plus Ix minus I1. My direction, current direction same, plus 2V3. Then here current is I1 minus Ix. This current going upward, I am going opposite. So minus R4 1 minus Ix. Going from positive to negative. Plus 4Ix. Minus V1. Minus R1 I1. Equal to 0. This is second. So second equation I started here and came to same point. Algebraic sum of the voltages in the loop equal to 0. And solve for Ix. Solve for Ix. So here R1, R2, R3 like that I have taken. If numericals are given, you can easily find out Ix. So mesh and nodal is very, very important. Any topic you take in the networks, compulsorily, knowingly or unknowingly, we apply nodal and mesh analysis. So all of you should be thorough with nodal and mesh, especially super node concept, super mesh concept. Sign convention is very, very important in this. Now let us take next problem. Yeah, before that there is another power supplied by current source. Power supplied by current source. And also power dissipated by 2V3. 2V3 is here. So what is the sign convention here? For example, there is a voltage source V. And current is flowing from negative to positive. When current flowing from negative to positive, so it is supplying. Power supplied is positive. When power supplied is positive, what is power dissipation? Is negative. Power dissipation is negative. This is one convention. What is other convention? Current may go down. Current flowing from positive to negative. In this case, power dissipation is positive. If dissipation is positive, then power supplied is negative. Power supplied is negative. Normally, when current is flowing from negative to positive, it is in supplying mode. It is supply the power. If they ask what is the power supplied, you should tell positive. But if they ask question reverse, power dissipation, you have to tell negative. But what is the change between these two here? Current flowing from positive to negative, then source is absorbing, dissipating. Therefore, dissipation is positive. But if they ask supply reverse question, you have to tell minus. This is about the sources. But if it is a resistor always dissipate. Don't worry what is the current direction. Current is going this way or this way. Power dissipation is always positive. If dissipation is always positive, what is supplied always negative. So this is the sign convention you should remember to answer such type of questions. Next, power supplied by current source. So current is known, now you have to find the voltage V. You have to find voltage V whatever way you want. Let us take this is V. So how to find V? This side I have taken positive, this side I have taken negative. So find out this voltage, then find out this voltage. This voltage minus this is nothing but V, and we want power supplied. This current is flowing from positive to negative. When current is flowing from positive to negative, what is supplied? Supplied is negative. So what is the answer here? Power supplied is negative minus V into I. Minus V into I. This I is known, this V you have to find. But how do you find this V? Voltage across current source is not zero. Find out voltage here, find out voltage here. That difference become V. V into I multiply, that is the power. You are taking negative because current is flowing from positive to negative. When current is flowing from positive to negative, supply is negative. So what is the question? Power supplied by current source is minus V into I. The same way, power dissipation in 2V3. What is this 2V3? Is a voltage source. And we should know current. What is the current flowing here is this. So find out this. But how this current is flowing? Flowing from positive to negative. Current is flowing from again positive to negative. What is asking? Dissipation. Then what is the dissipation is? Positive. So this source, what is the power dissipation is? 2V3 into I plus Ix minus I1. Because we want power dissipation is positive. So plus. Why this is positive? Current flowing from positive to negative. Here also current flowing from positive to negative. 2V3 multiplied with this. So this simplification will give power dissipated by 2V3. If they ask power supplied by this, then you take a minus sign. Like that all combinations we can work out. Here I am solving only these two. You can put a question yourself. Power supplied by V1, power dissipated by 4Ix, power supplied by V2, power dissipated in R3. Like that so many questions you can put it. And what is the total power in the whole network? Total power dissipation in complete network is always 0. What is the total power supplied by complete network is again 0. So that is as per the law. So this is one important model. Next question. Voltage source equivalent. This is based on source transformation. Voltage source can be converted to current source into voltage source. So what are the basic rules you should know in this topic whenever you are applying source transformation? If two voltage sources are in series, this is the voltage source symbol, V1 R1. There is another source connected in series, R2 V2. Two voltage sources in series we can combine. How we can combine? R1 R2 1 plus R2. Here V1 plus V2. 1 plus V2. Voltage sources series we can combine. But voltage sources parallel directly you can't combine. After converting into current source only we can combine. The same way, two current sources parallel. This is one current source, R1, a current of I1. This current source parallel with another current source, I2 R2. So two current sources parallel, we can add them. So what is the resultant? This is I1 plus I2. I1 plus I2. Then R1, R2 are parallel with R2. So two current sources parallel we can add. Two current sources series we should not add. two voltage sources series we should add, two voltage sources parallel we should not add. These are the basic rules. Then coming to conversion, how to convert voltage source into current. So this is one voltage source VR, which is equivalent to a current source of I. What is this I value? V by R. And this R must be connected in parallel. So this is a current source equivalent, this is a voltage source. We convert voltage into current, current into voltage using source transformation formulas. So if you know this much, you can answer this problem. Now if you observe this voltage source, they are connected in series. But here there is one current source, one voltage source, you can't add them. This and this you can't add them because these two are not parallel. These two are series, but this and this not parallel, this and this not parallel. So what is the best way to combine these two? Convert this into voltage source, that and this become series, you can add them. So you will get a voltage source equivalent, but this is again another voltage source. These two cannot be added directly. Again convert into current sources, then add. So that's how you have to do it. So let us convert this into four and 6 series. 4 and 6 series, so 10 volts. 2, 3 series, 5 ohms. Convert this into voltage source. 2 into 2, 4 volts. It's 2 ohm. 2 into 2, 4 volts. It's 1 ohm and 3 volts. So we have to combine this. Volts, 5 ohm, 2 plus 1, 3. Here 4 and see the polarity. Here 4, this side positive, but here 3, this side positive. So what is the total equivalent? 4 minus 3, that is 1. Now these two cannot be added. 10 plus 1, 11 like that you should not do. Is the common regular mistake. Now change this into current source. Change this into current source. Two current sources parallel we can add. So this is 10 by 5. 10 by 5 is 2 amps. 5 parallel. 3 is parallel. 1 volt, 1 by 3. 3. 2 amps, 1 by 3, you can add them. That is 6 plus 1, 7 by 3. 1 by 3 amps, 5, 3 parallel. 3 parallel. So this is current source equivalent. If you want, you can change into voltage source equivalent. So this is the importance of source transformation. Same problem connected like this. If it is connected, then if you change this into voltage source, no use. If you change this into voltage source, this you can't combine, this you can't combine, this you can't combine. So in that case, compulsorily change this into current source, change this into current source, change this into current source. These two parallel add, these two parallel add. They again both convert into voltage source, add. So depending on this small change, so everything will be disturbed. So be careful when you are using source transformation. Let us take next problem. Form factor. This is based on average and RMS value. How to find the form factor? What is the form factor definition? It is RMS by average. RMS by average. So you should know how to find RMS value, you should know how to find average value. Average value, you can use formula. What is the meaning of average? Total area divided by total time period. Total area divided by total time period. So how to find average? What is the area of this? Half into base into height. Half into base into height. This area, but this area with the negative sign. Area S. What is this gap? 4 minus 2 is 2. And this peak is negative minus 4. This is total area divided by total time period of 4. So this 2 will go 4 minus 8 by 4 minus 4 by 4 equal to minus 1. So minus 1 is the average. This negative area is dominating, so average we got minus 1. Next to RMS. RMS you can't apply this area rule, compulsorily use formula. So how to use formula? Before you use formula, you should know this equation. What is this equation? It is like a y equal to mx plus c. So what is the slope? Negative slope. This height is 4, this is 2. 4 by 2, 2, negative, minus 2t. Minus 2t. This line is giving 0 value at t equal to 2. This line is giving 0 value at t equal to 2. So if you replace t with 2, it is becoming minus 4. But what we should get is 0. So add plus 4. So this is a shortcut technique how fastly you can find the straight line equation. Without this equation you can't find RMS. So RMS formula is square root of 1 by 4 integral 0 to 2 and this equation minus 2t plus 4 square t plus integral 2 to 4. 2 4, this is minus 4 square. RMS means root mean square. So mean is by 4 total period, root is there, square is there. This is the formula for RMS. I am not doing detailed integration of this, but if you do it, you will get 3.83. So 3.83 is the RMS, average of minus 1, substitute you will get the form factor. In the exam sometimes they ask only average, sometimes RMS, sometimes form factor, sometimes peak factor. Peak factor is peak value by RMS. Sometimes sinusoidal, sometimes non-sinusoidal, sometimes sinusoidal with the same frequency, different phases, sinusoidal with the different frequencies with the different phases. So it is another big topic, important topic. So I have solved one problem, how to find form factor. Normally whatever you study at BTech level is only 20 to 30%. 20 to 30% only you study. But this is not sufficient for writing GATE exam or any other competitive examinations. So lot of remaining depth of concept is also there. Unless you improve that, you cannot get good marks in any competitive examinations. So let us take another problem. This is find I. Find I. There is one inductor, 1 Henry, and capacitor with 1 Farad, independent DC voltage source, and independent AC voltage source, 5 cos 2t. So AC voltage source, DC voltage source, resistor is there, inductor is there, capacitor is there. Find this current I. And you can't use nodal or mesh analysis here. The beauty of this problem is 90% of the students, they try to write nodal equation or mesh equation and solve, end up with the wrong answer. The biggest drawback of nodal and mesh is when network contains sources with different frequencies, you should not use nodal or mesh analysis. What is the unique drawback of nodal and mesh? If network contain more than one source having different frequencies, you should not use nodal or mesh. What is the DC signal frequency? 0. What is the AC signal frequency? 2. So definitely they comes under different frequency category. In that case, the best technique is superposition theorem. Superposition theorem. So superposition theorem is a small theorem. Directly gate point of view not useful, but indirectly when nodal mesh fail, then you can use superposition theorem. So here we have to use only superposition principle or theorem. So using that, what is the technique? I is equal to I1 plus I2. I1 with only DC source, I2 with only AC source, then add both, you will get the answer. But with the DC, what is the inductor behavior? For DC voltage or for DC signal, inductor is short. Inductor is short and capacitor is open. This is valid in steady state. Is valid in steady state. So it's a steady state analysis problem. Inductor short, capacitor open. So imagine this is short, this is open, or let me draw. Inductor with short, capacitor open. This source I am not considering. Voltage source not there means short. Current source not there means open. Is 10 volts. Is I1. Inductor short, capacitor open, voltage source short, find I1. So we can answer easily na I1. I1 equal to 10 by 2. It's 5 amps. Next we have to find I2. So how to find? To find I2, consider this and don't consider this. That means, so I am removing this. Voltage source short. Now inductor is there, capacitor is there. It's a AC source problem. 5 cos 2t plus minus. Here 1 farad. What is the capacitive reactance formula? X equal to minus J by omega C. What is omega 2? Is the capacitor value 1 farad. So it is minus 0.5 J. So capacitive reactance minus 0.5 J. Inductor replaced with inductive reactance. XL equal to J omega L. J omega is 2, L is 1, so 2J ohm. 2J ohm. 2J ohm. This 2 ohms as it is. This current is I2. If it is AC source, it comes under steady state analysis. Inductor replaced with inductive reactance, capacitor with capacitive reactance using these formulas. And it is a single source problem. You have to find I2. So what is the powerful step is, first find this voltage and also convert this into phasor form. That is 5 at an angle of 0. This cos need not convert into sine, and this 5 I am taking as it is. It is a RMS, maximum value. This 5 I am taking maximum as it is. Cos is the single source problem. Cos itself I am taking as a reference, so I can take 5 of 0. If I take 5 by root 2 of 0, 5 by root 2 become RMS value. Later again I have to convert into maximum time waste. So simple understanding is I am taking maximum as it is. So find this voltage first. This voltage is some Vx. And how these two are connected? They are in parallel. These two are parallel series with this. To find this voltage with the help of this one. So what is the powerful step is? Powerful step is 5 of angle 0 is the source. These two are parallel, that is series. That means we are finding voltage across this equivalent. So 2 parallel with 2J divided by 2 parallel with 2J minus 0.5J. So this simplification will give what? Voltage at this point, that is Vx. But we are looking for current, na? So this whole value divide with 2, you will get current I2. Get current I2. So for simplification you need calculator. Later you check it. You will get answer of 4.47 angle of minus 26.56. This is in phasor form. Convert into trigonometric form. Again you will get this 4.47, attach cos function, cos 2t minus 26.56. So this term is I2, this term is I1. I1 plus I2 is the answer. So like this we can solve when we have more than one source with different frequencies. Sometimes they give this is also AC, this is also AC, but this frequency may be W1, this frequency may be W2. Again I want to find I. Two frequencies are different. Na? You have to find separately I1 because of this, I2 because of this. Then add I equal to I1 plus I2. If both are DC, inductor short to capacitor open, straight away you can do it. So examiner always test you whether you know this or not. Examiner will test you whether you have a clarity when to apply, when you can't apply, or where to apply, where you can't apply. So such kind of things they expect because of competitive examination. So you should be careful. So let me take another question. All powers. This is based on power calculation, power concept. In the syllabus, if you see, they ask only a one single word, power factor. Power factor. They write this word, only this word they write. What is power factor is cos theta. But if you know only cos theta, power factor over, my syllabus preparation is over. No. So this topic is again another ocean, construction of power triangle. In that many things you should know. What are the different powers? So I asked a question, find all powers. These are the three different powers. One is P, another one is Q, then S. The different names for P is the real power, active power, actual power, only power. If they ask to find power, you have to find only P. Okay. Reactive power. Power. What are the formulas? Here you can use I square R, square by R, I cos theta, L part of VI star. So we have a 4 formulas. We don't use all 4 formulas. Depending on the availability of the data, we use it. I square R, V square by R. Most of you are familiar. But VI cos theta, real part of VI star. Then reactive power is square X or V square by X, VI sin theta, imaginary part of theta. Again we have a 4 formulas. This is apparent power or a complex power. Apparent power, complex power. This is also called as a true power. False power. This is useful power. This is useless power. We come across different words, and power triangle is this. Any inductive load, this is P, this is Q, this is S, this angle theta. So this will form a power triangle. P, Q, S. It form a power triangle. Now in this case, all powers means P you have to find, Q you have to find, S you have to find. So some background theory I am explaining. And here AC source is given. Since we are dealing with power, compulsorily you have to change into RMS. So what is RMS of this by root 2 means? Root 2 will go 10 angle of 20. 10 angle of 20. That is the VRMS. 10 is RMS, angle of 20 degrees. Next, AC source is there na? What is the inductive reactance? J omega L. Omega is 10. Value 0.4, which is equal to 4J. 4J. So what is the impedance? Z plus J4. Plus J4 is the impedance. Now what is the current I? Is V by Z. What is V? 10 of 20. This is one basic problem. Useful, this concept is useful to solve many complicated problems. So Z is again 3 plus J4. 3 plus J4 is nothing but 5 angle of tan inverse 4 by 3. We will get 53.14 degrees. So simplify to angle of minus 33.14 degrees. So this is current I. So current we got it, this current. With the help of this current you can find P. So what is the P formula? I square R. I square R. What is IRMS is 2. 2 square is 4. 4 into 3. So 12 watts. So P is 12 watts. If we use V square by R also, same answer will come. But what is that V is not this V. V is not 10. 10 square by 3 you will get wrong answer. Remember, when you are using V square by R, V must be across R. I must be through R. But this V should be across 3, not the applied voltage. So that is important. If you find voltage across 3 ohms, current is known, current into resistance you multiply, you will get voltage across resistor. Then V square by 3 will give same answer of 12 watts. Like that VI cos theta, all other methods you can try, you will get same answer. Then Q is what? I square X. So what is I square X? Again 2 square into reactance. Reactance is only 4. So 16 volt ampere. Units are different here. 16 VA volt ampere. P units are watts. Q units are volt ampere. Volt ampere reactive, VAR. And S is only volt ampere. Here volt ampere reactive. VI sin theta. Volt ampere reactive. This reactive word came from this. Every topic, lot of theory will be there. So everything I am not explaining. Then S equal to VI. S equal to VI. For S also 4 formulas. One is VI square mod Z square by mod z star. So using these four you can apply. Vi, what is Vrms? 10, Irms 2. So we will get 20. 20 Va. Of 12 square plus 16 square also you will get same answer 20. So like that power triangle or all powers can be calculated. This is one basic fundamental problem, but you all should know all these things. They ask the questions. Next question. Maximum power transferred to this resistor R. So maximum power transfer theorem. What is the condition maximum power transfer theorem? RL should be equal to RS. Load resistance, source resistance should be equal. Then only maximum power transferred. What is the maximum power formula? Equal to Vs square by 4 into RL. The maximum power transfer theorem is extension of Thevenin's theorem. So first you have to find Thevenin equivalent. You have to find the Thevenin equivalent. To know the value of R, we should know R Thevenin. To find the power, we should know V Thevenin. So this network, how to find V Thevenin, how to find R Thevenin. There are three different categories are there. All are independent, all are dependent, some are dependent, some are independent. This comes under which category? One dependent source, one independent source. So directly you can't find R Thevenin. V Thevenin we can find indirectly. V Thevenin is nothing but VOC, open circuit voltage. But R Thevenin is nothing but V Thevenin by I Norton. You have to find these two independently, then only you will get R Thevenin. That is the specialty of this model. Now how to find V Thevenin, open circuit voltage. So let me draw the equivalent circuit. We are finding open circuit voltage. AB, here R is open, removed, open. Rest of the circuit same, 2 ohm, 20I, 1 ohm, 1 ohm, 2 volts. This current I already given in the problem. Under this open condition, what is the voltage we have to find? So this is the current I already there. And what is the current here? Don't know. Let us take I1. If this is I, this is I1, this will be I1 plus I. Two unknowns, two equations. So here you can write one loop equation, here you can write one loop equation. So what is this equation is? Minus 2 minus I1 then plus I equal to 0, one equation, minus I minus 20I then plus here current is going this way, so opposite direction, minus 2 into I1 plus I equal to 0, second equation. And solve for I. For I. After you solve I, we want V Thevenin. Is V Thevenin start at A, go to B. So you can go this way or you can go this way. But if you go this way, problem is I1 plus I, both you should know. If you go this way, I is enough. So that is nothing but 20I plus I. So it is 21I. This I answer substitute, you will get V Thevenin. So V Thevenin answer, you will get 84 by 25. Next, you have to find the short circuit current. You have to find the short circuit current. But this AB is shorted. Current is ISC. This is ISC. What is the current here? 0. So this current is ISC and this current is ISC. Here this current is I is entering. This is ISC. Here also 0. This is shorted. So current here also 0. This is ISC. Here I plus ISC. I plus ISC. So like that, use current distribution and write one mesh equation. You know how to write mesh equation. Solve for ISC. Solve for ISC. Just with the help of mesh, you write ISC. You will get 2 amps. What is R Thevenin? VOC by ISC. What is VOC? 84 by 25. ISC is 2 amps. So it will be 42 by 25 is R Thevenin. When R Thevenin is 42 by 25, what is the resistance R using maximum power transfer theorem? 42 by 25. Substitute here. What is the Vs is nothing but V Thevenin. That is 84 by 25 square divided by 4 into RL. What is RL is 42 by 25. So simplify, you will get the answer like this. So maximum power transfer is important because indirectly they also test Thevenin's theorem. So this is one problem I am solving in this theorem. This is another excellent problem in transient analysis. Transient analysis. Switch K posed at T equal to 0, find IC 0 plus and VL 0 plus. IC 0 plus, VL 0 plus. So that is a question. Closed at T equal to 0. Whenever they ask a question at 0 plus, immediately you go back to 0 minus. So draw the equivalent circuit at T equal to 0 minus. The 0 minus is always steady state. 0 minus is always steady state. Steady state inductor is short, capacitor is open. So under that condition, so minus we are discussing, switch is open. The capacitor is open in the steady state. Inductor is short. Applied voltage of 60 volts. Ohm 1. Here capacitor is there, inductor. So steady state, what we can find? VC 0 minus. VC 0 minus. Steady state in the inductor, what we should find is IL0 minus. IL0 minus anyway 0, IC0 minus anyway 0. So what we are interested here, voltage here, current. So this is the equivalent circuit at T equal to 0 minus. Now this loop is open, this is open. So current will not flow here. Then what is IL0 plus? IL0 minus. Voltage 60 by 2 plus 1, 3. 20 amps. IL0 minus 20 amps. Next to VC0 minus. Voltage across this. So what is the rule? Started positive, go to negative. But we can't go like this. What is the voltage here? Don't know. Better go this way. To negative. And what is the drop here? 0 because it is short. What is the drop here? 0. Current not flowing here, not flowing. So you get only voltage across this. But the 60 is dividing between 20 and 1. So what is the voltage here? 60 into 1 by 3. So it will be 20 volts. So voltage here is 20 volts. Positive, negative. Going from positive to negative, again you will get to 20 volts. So VC0 minus 20 volts. VC0 minus always equal to VC0 plus. IL0 minus always equal to IL0 plus. What is the question? Question is not IL0 plus VC0 plus. If they ask this, that is easy question. But question is IC0 plus VL0 plus. So to answer that, we have to draw equivalent circuit again at 0 plus. At 0 plus. So I am removing this. Equal to 0 plus. It is not a steady state, it is transient. It is initial, you can say initial. 0 plus initial state. It is closed. It is VC0 plus, replace capacitor with voltage source, inductor with current source, volts as it is, 2 as it is, 1 as it is. VC0 plus we got 20 volts. VL0 minus we got 20 amps. We want VL0 plus. This is VL0 plus. IC0 plus. This is IC0 plus. So that's why this is important. Voltage across inductor. It is, don't think voltage across current source is 0. No. You started positive, go to negative. Therefore, VL0 plus answer is going from positive to negative, we will get 20 volts. This is easy. Next, IC0 plus. To find this current is 20, this current we have to find. But this one parallel. What is this equivalent? 1 parallel is 0.5. 2 and 0.5 series. So what is the total current here? 60 by 2.5. 60 by 2.5. This current to find out. Then both are combining. The net current flowing through this also same. What is 60 by 2.5? 60 by 2.5. 34 amps. So this current is 24 amps. The net current entering is 24, but here 20, if you use KCL, this must be 24 entering, 20 going this way. What is the current this way? It must be 4, this side. What is the current here? No, small mistake. The current here will be, what is the voltage here is 20. What is the voltage here is 20. What is the voltage here is 60. Remove this. So voltage is 60. Voltage here is 20. What is the total current is 60 minus 20 by 2 plus 0.5, 2.5. This is nothing but 40 by 2.5. 40 by 2.5. 16 amps. 16 amps. So here 16, but this is 20. What is the current going upward? 4 amps. This 4, this 16. 16 plus 4 become 20. 4 going upward, but what is the question asked? Downward. So IC0 plus will be minus 4 amps. And VL0 plus is 20 volts. So careful here. So IC0 plus VL0 plus is tough. VC0 plus IL0 plus is easy. This is another interesting question in transient. Switch K closed at equal to 0. Find I1 infinite, I2 infinite. Infinite means steady state. Steady state, this inductor is short, this inductor is short. So students commonly they do mistake like this. Switch is closed, 5 ohm, this inductor is short, this inductor is short. Two Henry shorted, 4 Henry shorted, and 5 ohms, 10 volts. We want this current, I1 infinite, this current I2 infinite. Common mistake is they think that this is short, this is short. So 10 by 5, the current is 2 amps. 10 by 5 is 2. So this is short, this is short. Some students will give answer, this is 2 and 0. Some students both are short, equally divide 1, 1. So different combinations. 2 and 2. These are all possible mistakes. Even though inductors are there, even though both are short circuited, and you have to use current division formula. What is the current division formula using? I1 infinite. What is the incoming current? 2 amps. And how these two are connected? Parallel. Inductors parallel means you have to use current division. This formula is similar to resistors. So opposite is 2 divided by 2 plus 4, 6. So it will be 2 by 3 amps. Similarly, I2 infinite. Incoming is 2. I want this current opposite 4 by 6. So again it is 4 by 3. 4 by 3 amps. So I1 infinite is 2 by 3. I2 infinite is 4 by 3. 2 by 3 plus 4 by 3 is how much? Again you will get 2. So here inductors are shorted, parallel, and you have to use current division formula. Its dual problem comes as a capacitor that is also similar to this. This is another Little bit confusing, but try to understand carefully. What is the current given here? 4 amps. IR not given. IR plus IC become 5 amps. This is 5 given. And here 120 volts AC source. This current is 5, this is also 5. Question is to find this current IL. So it's a phasor concept, vector concept you have to use. And all are connected in parallel. Pure capacitor current leads voltage by 90 degrees. Pure capacitor current leading by 90 degrees. So what is this current given? 4 amps. This current given 4 amps. And IR plus IC is 5, but IR current is in phase with applied voltage. In phase with applied voltage. This IR not given, but resultant current is given as 5 amps. It will form a right angle triangle, and square root of I square minus 4 square. If you do that, you will get to 3 amps. So IR equal to 3 amps. This is 3 amps. Root of 3 square plus 4 square is 5. This is 5, this is also 5. IL is not 0. This is the common mistake. IL is not 0. This is 5, this is 5. This current is not 0. Magnitudes only equal, but IL is not 0. But for what value of IL, this current remain same 5 amps. So just conceptually think carefully. IL current of, if 8 ampere is flowing, out of 8, this total 8, this 4 down, this 4 up cancel, this 4 remain, and again 3, 4, what is this resultant will be? 5. So you are getting same current of 5 if IL value of 8 is flowing. So this current is 8 amps, not 0. So in this out of 8, 4 compensated here, still remaining 4 is there, this 3 there, 4, resultant becoming 5. So this current is 5, this current is 5, my conditions are satisfied. Therefore IL equal to 8 amps is correct. This is another problem in resonance. So a coil series RL has been designed for high Q performance. High Q means quality factor is very much high. At a rated voltage and a specific frequency. If the frequency of operation is double, then coil is operated at same rated voltage, then Q factor and active power P, how they are affected. What is the quality factor formula? Q, a series coil, that is omega L by R. What is Q1? Is omega 1 L by R. What is Q2? Omega 2L by R. So quality factor disturbed with frequency. Here frequency is doubled. Frequency of operation is doubled. If it is 2 times increased, automatically Q2 equal to 2 times of Q1. So quality factor will be doubled. That is simple. Then active power, how it is affected. This is connected to voltage source and frequency. Now find the current I. What is that current I will be divided by, what is the magnitude of current? V by root of R square plus omega L square. Because Z is nothing but R plus J omega L. magnitude is this, ratio will give current I. But we want to power. Power is nothing but I square R. So what is I square? V square by, then root will go R square plus omega L square into resistance R. This is V square into R by, we can write it like this, R is R square common, 1 plus omega L by R square. This is nothing but one R will go, V square square by R 1 plus Q square by R 1 plus Q square. So Q already given large, 1 is neglected. So therefore P is equal to V square by R Q square. So if it is Q1, this is P1. But what is P2? V square by R. Now Q2 square. What is Q2 square? Equal to 4Q1 square. 4Q1 square. So we will get 4Q1 square. This is nothing but P1 by 4. So power is reduced by 4 times. Quality factor is increased by 2 times. That is because of frequencies doubled. Like this we can answer. Last question. So this is the coupon code. If you use this coupon code, you will get 15% discount, 15% discount. So you can use this coupon code to get the discount. The subject is very, very basic subject, very important subject. If you are good in networks, any subject, any circuit can be analyzed easily. So thank you. All the best.